Video number 225, prime numbers, prime factorization, and simplifying fractions. A prime number is a whole number whose only factor is itself. Of course, a number divides into itself only one time, so therefore that could also be mentioned as part of the definition if you choose. Here's a list of the first few prime numbers, and obviously on the list every number here is odd except for 2. And notice 51's not on the list because 51 can be written as 3 times 17. Is 65 prime? No, we would describe 65 as composite, as 5 and 13 are considered factors of 65. Is 67 prime? Yes, because 67 can only divide by 67 just that one time. Write the following as product of primes: 22, 450, 51, and 71. Here we go. 22 obviously is 2 times 11. Both those numbers are primes, so therefore we have a product of primes. There you go. We start off with a product for 450 as 10 times 45. We change the 10 to 2 times 5. There's your primes. Change 45 to 3 times 3 times 5. This is actually a correct product of primes. And then just to make things simpler, we take our 2 3s, put them together, 2 5s, put them together. 2 times 3 squared times 5 squared. There you go. Alright, 51 is definitely 3 times 17. That's a product of primes. And we have 71 as a prime number. Here's another way to have done the 450. We could have started off with 9 times 50 rather than 10 times 45. And we then break the 9 down into 3 squared. Of course, 50 is 5 times 10. Break the 10 down to 2 times 5. We have 2 5s, 2 3s, 2 times 3 squared times 5 squared. We're all set. Now we're going to go ahead and simplify a couple fractions. 35 over 45. If you have watched the previous video here when we talked about the basic concepts of a fraction, we would know that this is actually an undefined fraction because the greatest common factor between the numerator and denominator is not 1. Here actually we can divide by 5, and that's exactly what we are going to do. We could rewrite 35 as 5 times 7. We can definitely rewrite 45 as 5 times 9. Therefore, 5's cancel. We have 7 ninths. 24 over 16. You can rewrite the numerator as 4 times 6. Denominator is 4 times 4. Then we break down the 4's as 2 squared and 2 squared, or just rewrite it. It's not really a breakdown, just rewriting 4 as 2 squared. Then we can rewrite the 6 as 2 times 3, write the 4 as 2 times 2. I do that because cancel. We're left with 3 over 2, which is 1 1/2. Now we have the greatest common factor method. Yes, we just did this problem, but here's a different method. If you were to list the factors of 16, you would get 2, 4, 8, and 16. However, the greatest that both 24 and 16 have in common are 8. So we would rewrite 24 as 8 times 3, rewrite 16 as 8 times 2. 8 divided by 8 is obviously 1. 1 times 3 halves is just 3 halves, therefore 1 1/2. We're going to be working on this mixed number idea in the next video. 35 over 70. We could do the prime factoring idea, prime factorization, but we're going to use the greatest common factor method instead because it's obviously easy. 35 times 1 and then 35 times 2, so therefore you reduce 35 over itself to become 1. 1 times 1/2 is 1/2. Okay? We could use 16 to reduce the 64 and 80. 64 is just simply 16 times 4. 80 is just 16 times 5. Cancel the 16s to a 4/5. However, let's just say, for example, you didn't know that 16 was the greatest common factor. What if you knew 8? Maybe you can just start off with 8. So you divide both numerator and denominator by 8, you get 8 tenths. Okay, there's your 1. Then you go ahead and reduce the 8 tenths down to a 4/5 by dividing both numerator and denominator by a 2. And we're in good shape. So you don't necessarily have to use the greatest common factor, but it is definitely a good idea to use a larger common factor than just simply the 2 here. Obviously 32 over 40. If you did that route, you'll eventually get to 4/5, but it's definitely going to take you much longer. So that's why you need to know your times tables, and you need to know how to practice. You need to practice your division, and definitely make use of the fluency worksheets. And good times. We'll talk to you later.